And this is how we actually start, and from this moment is where you're going to be able to go back to this training. Let me share with you a moment, just a little bit about what we're planning to do today. So if I have, sorry, just one moment so I can share what I need. Okay. Okay, can you see my presentation?
Yes.
Yeah, okay. All right, perfect, everybody. So let me go through a little bit of the agenda of what we're going to talk about today. Of course, we did some introduction. We went through Padlet. Please do add your location on Padlet. It's really important for us to see where you're coming from. Not because we care about where you're coming from, but it's also really good to create a kind of community, and we know where your needs stand the most. So it's really helpful for us. We are going through a little bit of the theory of EUMETSAT with Anumaya. Anumaya will explain us fires and related data products. We will then download Fire products through Data Store Graphical User Interface. If this is completely new for you, I am sure it will be really straightforward, but I would really appreciate it if you could. You might have received the email, but it's important for you to register to user portal so you will be able to then access the data. It's also important for you to check the licensing, because we have some licensing points that you have to follow for downloading certain types of data. So please do check out that if you haven't done so yet. After that, we are going to the demonstration of two Jupyter notebooks. So one Jupyter notebook is going to be for downloading the data. So it is basically doing the exact same thing that we are doing from Data Store Graphical User Interface, but we are doing it programmatically through EUMDAC. I also want to take the chance to tell you that tomorrow there is going to be a data access services training. I think Joanna, the person who is currently in charge of that, is in this meeting now. And please, if you are willing to learn more about EUMDAC, you can also register to that course. It's also free of charge. So you can check it out. And we have also, there is a lot of recordings that you can reach. Again, so we'll have this first Jupyter notebook for the download and the second Jupyter notebook for the visualization. And Noemi F is the person that has developed the Jupyter notebook. So in case you have any specific question and you would like to talk to her directly, please feel free to do so on the chat as well. And we are going then for the question and answers. As I mentioned, we are going to have this is 1 hour session. We have extended it to half an hour extra, so we have the time for you to ask the questions if you need. So said this, I think now it's the time to go for the actual science, and I will give my word. I will pass my mic. I wish I had a mic. This is something I always say. I wish I had a mic to pass it to Anumaya. Thank you, everybody.
Okay, thank you. So I will take it on here. And as Noemi said, so we are going through some very basic of the fire monitoring. So you can change the slide. And first of all, a couple of words about the EUMETSAT. So as said, we are the group of atmospheric composition, and we are contractors for EUMETSAT. EUMETSAT is a European intergovernmental organization with the member states, and the European it is responsible for the meteorological applications, but also much more. So, for example, EUMETSAT mandate is for the member states to plan and develop satellite systems. This is often done in collaboration with the European Space Agency and also with the Copernicus, so the European Commission and Union. EUMETSAT's mandate is mostly operating satellites. So it carries out a lot of operations with multiple satellites, and EUMETSAT currently operates satellites that are both in geostationary or in polar orbit. And here you can see a picture of different kind of satellites that the EUMETSAT is at the moment operating. So you can see there are the Meteosat satellites that are on a geostationary orbit, and then there are these Copernicus Sentinel satellites that are on a polar orbits. Yeah. And so if we now go to the actual topic of this course, so this is really a very quick scratch on the top of the whole topic, which is really, really complex environmental phenomena. So this short course, we are concentrating on active fires, so fire monitoring, and then the smoke aerosols. So those are maybe the two basic things if you want to monitor fires. So these are maybe the two most visible things that can be done using satellite observations. So as we know, the wildfires occur in many regions in the world, and many people are affected yearly. In some regions, this is like a regular and kind of, let's say, more or less natural phase of the ecosystem. But in some places, these fires are really not like natural causes, but really causing a lot of damage in the environment and also hazard to the people. And so what we can use the satellites for in fire monitoring is really multifold. So we can monitor both the active fires, how much land did the fires burn, and also the atmospheric emissions. So satellites are in a very good position for fire monitoring in that sense that we can do a spatially very extensive analysis. So with the ground-based measurements, for example, we cannot get the whole picture of these fires. And in this short course, so we will cover, as said, so the active fire and aerosol observations from the Copernicus Sentinel-3 satellite, sorry. Yeah. So I already mentioned a couple of slides ago that the EUMETSAT is operating both polar orbiting and geostationary satellites. So the Copernicus Sentinel-3 observations that we are covering today are from a polar orbit. And the polar orbiting satellite is flying from pole to pole, and it's covering the whole Earth about within 1 day or so. There are currently two Copernicus Sentinel-3 satellites, so Sentinel-A and B, and we will discuss them in more detail later on. And here you can see in the image, you can see an example of the fire radiated power observations from this Sentinel-3 satellite. And then EUMETSAT also has geostationary satellites that can also be used for fire monitoring. And here is the same quantity imagined from the geostationary satellite. So the geostationary satellite stays above the same location at all the time. The advantage is that you get over the certain area, you get observations every 15 or 1 hour or however it's defined. So you can get the temporal variation within a day from geostationary satellites, but the downside is that you cannot cover the whole globe with these observations. And so our focus today is the Sentinel-3 satellite. So as I said, there are currently two operational Sentinel-3 satellites, so Sentinel-A and B. They are on a polar orbit, so they fly from pole to pole at about 800 kilometers height from the surface. And the overpass times for these satellites are about 10 in the morning and 10 in the evening. So these satellites pass a certain location always at the same local time. So wherever you are, so about your local time, 10 in the morning, so these Sentinel satellites will overpass your location. And from these Sentinel-3 satellites, so EUMETSAT processes many data. So first of all, there is a lot of marine data that are processed from these observations. But then there is also the near real-time aerosol and active fire observations. And the Sentinel-3 is actually the name for the whole satellite, but the whole satellite then carries several different instruments. These instruments are, for example, the ocean and land color instrument OLCI and sea and land surface temperature radiometer, so SLSTR, which is our instrument of today. So the AOD and the fire observations are provided from this instrument. So, okay, so here is maybe a little bit busy slide, but I have here tried to sketch what this SLSTR instrument is actually measuring. So, first of all, the specialty of this instrument is that it is actually observing atmosphere from two different kind of angles. So the SLSTR is looking straight down, and then it has this kind of backward angle that it looks. So it has two views. And it has also a wide range of multiple channels that it measures the radiation. So the satellite instrument is measuring the radiation that is then converted into atmospheric or some other parameters. So the range extends from the visible wavelength, so about 0.4 micrometers to all the way to a thermal infrared. And by selecting these channels and combination of these channels, so we can use these radiation measurements to get information about aerosols. So when we combine the visible and near infrared observations together, or then active fires when we combine the near infrared and thermal infrared together. And I have here now a couple of very, very short and simplified, let's say, introductions to the actual parameters that we are looking today. So the first is about the active fires and the fire radiative power. So FRP, so we are talking about fire radiative power, so equals FRP. So that is actually a measure how fast the actual fire is releasing energy. So this is really related to the energy that the fire releases. Units also for SLSTR are given typically in megawatts. And when you have a high FRP values, that means that the fire is more intense. So low FRP is less intense fire, and high FRP is very intense fire. And this FRP is derived from the radiances that the SLSTR measures in the near infrared and thermal infrared channels. And the basic idea for not only the SLSTR, but any satellite observations to observe active fires is that they are observing pixels, satellite pixels that appear hotter than the background. So they are really monitoring the hotspots. And so that's how you can detect the fire, that the satellite notices that there is like a 1 pixel is significantly hotter than the wider surroundings, and there you can then conclude that it is most probably fire. So there is a very simplified schematic observation, but there is like the satellite pixels are these gray boxes, and then there is this one fire, and you can see that the one fire pixel is appearing much more warmer. We can say like it's a much more warmer than the surroundings, and there from these kind of observations you then define the FRP. Yeah, the next, please. The FRP is also because it's actually the satellite is monitoring objects that are hotter than the surroundings. So it is actually so that the FRP observations can also contain information, not only fires, but also other objects close to the Earth's surface that are not actually fires. There are a couple of examples here that, for example, there was a fire in the middle of ocean near the coast of Italy, and zooming in, actually, it was found out that it is an active volcano. So the volcano was kind of emitting something and appearing like a hot. So that was marked as a FRP, so fire or hot pixel. Then also industrial facilities can be detected as fires. So again, I have in the right, so there is an example of a fire that was showing up every day, multiple weeks in a row. Every day there was a fire in the same place, and that is typically an indication that actually it is not a fire, but it is some more static source, and in this case it was a big industrial facility. So that was a really, really quick course on FRP. So there is a lot of resources at the EUMETSAT data portal where you can find more detailed explanation of the fire radiative power and related things. So I also encourage you to visit there if you want to know more about this topic. And now we are speeding forward and moving already to the aerosol optical depth. The other measure, could you go one slide back? Yeah, this, yeah. So basically the aerosol optical depth is a measure how much there is aerosol. So these tiny particles, the smoke that you see in the air. So that those are composed, the smoke cloud is composed of these very, very small particles in the air, and they are called aerosols. And the aerosol optical depth is a measure that we can get from a satellite, and it tells us how much there is aerosols in an atmospheric column. So atmospheric column in this case is this kind of pillar that extends from the Earth's surface to the top of the atmosphere. And we use solar light to measure this aerosol optical depth. And two important things here. We cannot get the aerosol optical depth information when there are clouds or when the surface has some snow or when the sun is not when there is not enough sunlight. And the SLSTR instrument is providing us the near real-time AOD, and it is reported at the 550 nanometers wavelength. So what I could also mention briefly here is that typically the AOD is reported at 550 nanometers, but the AOD value, so the value itself, it's dependent on the wavelength. So that's why we often say that at which wavelength this number is reported. AOD itself, it's a unitless number, so if you are not working with this, so this is a little bit strange parameter, so because it's just a number that goes from 0.05 to maybe 3 or even 4 in some cases, and it doesn't tell you, it doesn't have units or so it's a not maybe the easiest parameter to really interpret. If you average everything globally for multiple years, so the global mean, depending on satellites or satellite instruments, so the global mean AOD at 550 is about 0.1. And for AOD, because this is kind of really satellite-specific parameter, so there is not any thresholds when the AOD is high or when it is low. So I have just gathered here a list, like by pulling out of my sleeves some numbers. So you could basically say that when the AOD is below the global mean, you can say that AOD content, the aerosol content is low. When it's more than 0.2, it's elevated, and then very high when it's above 1. But these are no means by any official thresholds. So here I have an example of one-day image from the Sentinel-3A and B combined observations, and you can see that this is very typical view of the AOD map for one day. First of all, you notice that there is a lot of missing areas. The missing areas when there is no observations but just white map, so those are mostly because of clouds. Also in the north, it can be that there is like not enough sunlight, or then there is even snow on the ground. But then you can also see some elevated values, and sometimes these missing values can also be missing when we have a very thick aerosol plume. So actually the algorithm thinks that this is actually a cloud and not aerosol. So this is a very typical example of daily observations. Yeah. And then we can, of course, the purpose of this whole short course is to demonstrate you how we can analyze the fire cases together. So, of course, the analysis of the FRP and AOD is very good way to interpret what kind of fire emissions we have. And the advantage for this SLSTR instrument is that we get the AOD observations and FRP observations from the same instrument. So there is no temporal gaps or any like spatial gaps here, but these are the simultaneous observations you get from AOD and FRP. And I have circled here now some areas where we have some maybe images are a little bit tiny, but if you download these slides from the classroom page and then take a closer look, so you can see that where we have a lot of fires, we also typically have elevated AOD values, and that is an indication that we have the fire emissions. Yes. And here a little bit closer look for over Africa. I wanted to show this example because this also shows an elevated AOD values that are not related to fires. So fires are not the only thing that increases the AOD. In the Southern Africa, you can see that definitely there is a lot of fires, and you can see also that there is a high AOD. But then in the north, in Morocco, so you can see that there is actually a very strong AOD enhancement observed, but no fires, and that is then most likely to the to dust. So what I would like to say with this slide is that that the AOD itself as a value do not tell you what type of aerosols they are. They just tell you that there is a lot of aerosols, but you need to then figure out the cause by using some additional observations like FRP.
And Maya, just for you to know, we have 2 minutes left.
Yes, and this is my last slide now. Yeah, so for this course, we are now also using the SLSTR observations. Last summer was a record-breaking summer in terms of fires in Spain and also in Portugal. So we had a very intense fire season happening in Spain, especially in mid-August. So when there was emissions peaked a lot. And now in this course, we are going to show you one day of observations from FRP and AOD from SLSTR. And over to you, Noemi. Yeah.
I was muted. Thank you so much, Anna-Maya. I would like to take the moment just to answer Rita. Yes, you will find the recording available on the classroom page, and thank you so much, Victor, for already answering for us. As Mohammed is sending, it's the classroom page is available, so you will find this recording right there. And thank you, everybody, for everything and for already helping us from in the chat. Thank you so much, Anumaya, for your great explanation. As Anumaya mentioned to you, we are touching on two products. Here in this page, in these slides, you will be able to download them from the classroom page. There are also some links that you might find useful, such as the user portal, well, the classroom page, the data store user guide, and the EUMETSAT guide that we will be showing you in a little bit. So at the moment, what I would like to do is showing to you all how we are going to download these products that Anumaya has just explained, so FRP and AOD, from the data store of EUMETSAT. We are using data store and we are using the web service. We are going through the data catalog, and I will show you how to select this certain date. Of course, I'm assuming that we already know the event, so we know the fire event we want to study, so we know which products we want to use, FRP and AOD, and we are going to download, in this case, just one of them for a matter of time, but Anumaya will show you basically the exact same thing, but through EUMETSAT. So if you give me just one moment so I can prepare my space. And I don't know if it's happening to any of you, but where I am, the sky just came down in the moment that Anumaya was speaking. Like, I don't know if that was for you, that happened to you too, but for me, it was like, I don't know. It was just, okay. Sorry, I'm just opening the right things. So we have them. I am going to show you how we are going to reach to the data store from our user portal. Okay, so we start from the very, very beginning, assuming that you have never downloaded anything. Of course, for many of you, this will be repetitive maybe, because you are probably part already of the EUMETSAT community and you have done this many times, but for everybody that maybe is not fully comfortable, then we are sharing this, okay? One more moment. Okay. Okay. I guess you can see my screen. So I'm in the user portal, so just a simple user portal, user.eumetsat.int. So everything that you're looking for when you're looking for EUMETSAT data, it's always going to be here. You can log in here. Of course, I would really appreciate if you have already logged in because it's quite important. And then you can, from the dashboard, well, you get to see classic event and notifications and some stories, but we want to go to data access in this case, and we want to go to data store. You'll have some detailed guide here, introductory guide and detailed guide. Everything of this is really well explained in the data access services trainings if you want to get deep into that. But right now we are going directly to data store. As you can see, this is also reachable from data.eumetsat.int, so really easy. But in this case, we're just going from the user portal. So if we are following what Anumaya just said, we are looking for something specific. So we are performing an advanced research. We know that we want Sentinel-3, because Anumaya mentioned it before. We know that this is the sensor that we want, SLSTR. So, and we also can, well, if we want, we can already put other types of filters. This is not my case. Just right now I'm putting aerosols, so I know that it's going to bring me to aerosol optical depth. You can always search it just here. If you want aerosol optical depth, you can just search it. But in case you want to filter more and you want to try it out. You can read more about the data just right here, so you can get to know how it's distributed, the contact, technical detail. Especially you might be interested in the temporal extent right here. So this is quite a comfortable way. Let me go back. So we have this. This is telling us this is Leo, as we mentioned, Sentinel-3. So we are going now to access the data. So in this case, what Anumaya will be showing you in the Jupyter notebooks, we are going for something specific, okay? We are going for August 2025. So when we said we had a lot of this data, well, we had a lot of fires and of course data related to that. And we are going here, we are going to search, and let's say we're going to August 16th. From, let's say, 11 to August 16th. Again, we want to have, for example, 1 hour, okay? So we're having 1 hour. And we are going to also give some area of interest. And you can always search your area of interest with these little commands here. You can just make polygons. But in my case, I already know the area of interest. I already have it here in coordinates. So this is what I am just doing now. And I'm showing the results. If you see well, I have two results here. I have one here. One is this one, one is this one. As you can see, it's moving. This is the one that we want because, of course, we are talking about Spain and Portugal, Iberian Peninsula. So this is probably the one we want. And you can download it directly from here. You can always access from add it to the cart, and there is some other customizations that are available. We are not touching customizations today. If you want to know more, again, data access will have really good explanations. And we also, if you're interested into knowing how you want to transform certain data that you find more comfortable, just let us know. We are really happy to then create something and focus also on that, how you can tailor data according to what you want. But in this case, we are just downloading Sentinel-3 data. I can just simply download that. Of course, I need to log in. This is not the case right now, but if I'm logged in and I have the right accesses, I shouldn't have any problem. You also get to see here some information about EUMDAC. So this is what Anumaya will use right now in her Jupyter notebooks to download the data. So EUMDAC is basically a Python library that is created on purpose for you to easily connect with the data store. Here you have the collection ID for this specific product, and of course the product ID. You can either copy them, in this case we don't need it, or you can add it to the cart. So this one is the really simple way for you to download data when you just want to see them, like easy peasy, and you want to see them on the map and you want to check the dates. You can filter them and make sure that you download the right product. I would go to the FRP as well, but I don't think we have the time, so I think it would be more worthy for you to actually look at what the Jupyter notebooks are going to do. Of course, the Jupyter notebooks are available for you. For anything you need, you can access them. There is on Classroom page the link, but of course you can go through EUMETSAT Git and you will also find them there. This is basically, if you're a really basic starter with this data, this is a really easy way for you to see the data and download it as you wish. Of course, assuming you already know the area. Otherwise, there are of course many other ways for you to check out a specific area, such as EUMETView, which is a great visualization tool, which we will not touch today. But this is exactly how if you're assuming you want this specific date, you want to download this product, you can download it and then visualize it as you wish. If you want to use GIS, the data, the native format for Sentinel-3 from EUMETSAT is netcdf. But of course, through the data tailor, you can also change the format and choose the format you want, depending, of course, on what you need. Okay, so I am going to stop sharing right now, so we have a little bit more time to go through Anumaya's demonstration. And maybe Anumaya, while you are setting up your desk, I would your screen. Does anybody have any specific question that you would like to ask before we go through the Jupyter notebook? Something that you would like us to touch right now? If you do, the question and answers are right here, and the chat, of course, is being monitored also by Noemi. Thank you, Noemi, for the message. Okay, so I don't think anybody is having any question at this step. So we can go for the Jupyter notebooks. Anumaya will explain you exactly how from your Classroom page, you can get the Jupyter notebook and run it on the Wikio environment. Of course, you have to be registered on Wikio to be able to have your space. You have received this in the email, so I'd be happy to, if you need anything, just let us know, but you should be able to easily access. Anumaya, I'll again pass the mic to you.
Yes. Thank you, Noemi. So yeah, let's get our hands on to the data. So first, what I'm going to show you is the course classroom page. So there you can find all the relevant links and for the resources. So first of all, the presentation. If you want to go back on theory, so presentation, the slides are found here. But for the really hands-on exercises, so we need to access the GitLab where you have the Jupyter notebooks, and the link is here. So by pressing this link, so you will end up to the correct folder in the and repository on the GitLab. And what we would need to do here now is that before going to Wekeo and having these notebooks, so we need to download these notebooks here to our own computer. So basically, also here in the GitLab, so you can view already how these notebooks look like, but then you will have the download button, for example, here that downloads these files locally to your computer. And what do you need to download here in order this exercise to be successful? So it is these three pieces of code. So these two are Jupyter notebooks, and this is a Python code, this helper function. So these all you need to then download. And it is very important also for you to be able to run these exercises that you have already done the signing in to Wekeo. So Wekeo is the platform that we are actually using for this exercise. For many reasons, from Wekeo you can use the EUMDAC to access the EUMETSAT data. And also it is already a Python platform that you don't need to do any local installations on your computer. So I hope that you have done this registration. And I know that this is going to be now quite a quick exercise. So once this recording is out, so please go to the classroom and then find this recording, and then you can repeat this exercise a little bit slow and have a pause in the recording. So I'm going to I am going to this quite quickly now. So I have registered to Wekeo already well beforehand, and I have also used Wekeo quite a lot. So how we find here now the Jupyter space that we need. So we need to access the Wekeo workspace. So you see that I am logged in. I click here the Wekeo workspace, and now this opens. And as you can see, my workspace is quite full of stuff already. I have here now created a empty folder so that you can follow up what we now do. So basically, if you haven't worked with Wekeo beforehand, so this is about the setting that you will be seeing once you go to the workspace. And now the next step is that we need to get these notebooks to Wekeo. So I have already downloaded this beforehand to my computer. So what I'm just going to do here is, let me show once more. So here is the button that you can upload material to your own Wekeo workspace. You take these three things and you upload, and they should appear to your Wekeo workspace. And now we are going through the first Jupyter notebook. So this is really getting the data from using the EUMDAC. So getting the Sentinel AOD and FRP data, and here is how we are going to do it. And the first time you are opening these notebooks, so the Wekeo is asking you for the kernel that is to be used for these notebooks. And here it's important that you select now, you use the Wekeo Lab kernel. So the Wekeo Lab is a kernel where there is already installed multiple packages, and all the packages that you need for this, in order to run these notebooks. So Wekeo Lab is the one that we select. If you select the Python kernel, so it might give you an error that you don't have, for example, Xarray package installed or something like that. So we are now running this first notebook in the Wekeo Lab kernel, and in this notebook, so you have a very detailed explanations about the fire-related power and the AOD observations that were already covered in the theory slides. So I am not going to pay too much attention. So the FRP is given from SLSTR as a 1 kilometer resolution product, and the AOD is about 9.5 kilometer resolution. And now, in order for you to be able to run this notebook, so you really also need to be having these licenses accepted at the EUMETSAT data services. So if you don't have these licenses accepted, so you will get error messages while running this notebook. So first of all, you can see I run the first shell of the notebook. It imported many libraries that we are needing. You can see that here we also import EUMDAC, so I didn't need to do in this Wekeo Lab any installations, but the EUMDAC is already there. And also, while importing these packages, so we also created here a products folder. You can see it appeared here, where we have subfolders AOD and FRP. And this is now also used in the second notebook. So in order, if you want to bring and manually download your data, so in order you to be able to run the second notebook where we actually plot the data, so it is assuming that you have similar kind of data folder structure than we have here. So then you need to create these folders or otherwise modify the second notebook if you are bringing in the data manually. But now we are using the EUMETSAT, so we are using first for FRP and then for AOD. And the first thing is that we need to kind of have the credentials to actually access the data at EUMETSAT. And this is now related to the licenses that you have already also accepted. Because I have worked with this data before, so I have already created these credentials for myself. But basically, when you are running this cell, so because I have already done this, I get only this token and the information on the token. But when you are doing this first time, so after running this shell, it will ask you enter your consumer key and enter your consumer secret. And how you find this? It is you use this link that is here in the green box. So you use that link, and it will forward you to this kind of page. I have here shaded my username in order not to reveal too much about myself, but this is basically the page that where you will ending up. And from here, you use this this button here. You will click it. It will copy your consumer key, and then you will copy paste it. There is a space where you can enter the consumer key. Press enter, and then it will ask you about the consumer secret. Again, this page, consumer secret is here. You just copy it and then paste it here, and then you will end up having this token. And this is done here so that it is now creating this kind of hidden file so that you will not share all of your personal things to anyone. So once you do it this once, so then it is working. Then and you will get the tokens that you need then access using the EUMETSAT. You need to access the data store. So far, so good. So no error messages and everything is working okay. And we can, for example, now list here what kind of collections we have at the EUMETSAT and at the data store using this EUMETSAT for SLSTR. So we are requesting SLSTR level 2. And you can see the listing here of multiple products. Maybe you already remember now from Noemi's presentation that there was this kind of identification number for these certain products in the data store, and this is also these identification numbers are also important now to remember when we are working further with this data. So for this exercise we are using the aerosol optical depth and fire radiative power. And if we want to get the listing of the fire radiative power, so you see we take the collection ID here, use it here, and then we request that collection. And so far so good, still no errors, and I'm amazed. So everything runs smoothly. And we have now specified our collection. So we are now accessing the fire radiative power from Sentinel-3 level 2 SLSTR. And for example, we can get the latest collection from our product. So we will run this shell, and you can see, okay, today is year 25, it's November 25th, and we have the latest observations are coming for the FRP are coming 11 hours, so 11, 23, and so on. So this is the latest observations that we have. We can also then download actually this product to our Wekeo working space. And now you see that we are creating here another folder, so S3 folder, and we can download the latest product to our folder. So if we now go here, we should have, yes, we have the S3 folder, and now we have the latest product here. So the product is downloaded to our Wekeo, so it retrieves the product from the EUMETSAT data store and then stores it in our Wekeo workspace, our personal space, as a zip folder. So the next thing that we need to do if we want to use the data is that we need to unzip the data. And then we should have this new unzipped data there. So if we go again here, so this is, I think, I don't now remember which one is the, yeah, we have here the zipped folder is the white one, and then we have the black one is now the actual folder where we have the data. And you can really click here to the data and see what kind of things comes with are downloaded with the products. And here we have actually the actual data files. So they are either netcdf or CSV. And for this exercise, we are using the netcdf format. Okay. So now we got like the most recent observations. We can also specify the temporal like extent what we want. So we want maybe the 8th, we want more closely to our case of interest. So we want the mid-August. So then we can specify that August 15 and then the time, so hours and minutes. We can also do all kinds of searches. This is just an example how you can get the listing of all the observations that have been occurring during that time. And as you can see, there are many. So the FRP is stored from SLSTR in about 5-minute chunks. So the orbit is cut into little pieces, and that's why you get so many observations for that, even for that limited time period. But now if we go to really the data that we want, and we are basically doing here exactly the same thing as Noemi just did, showing from the data store like manually, so making the region of interest and setting the temporal time. So what we do here is that we are now trying to get the FRP values that we are wanting. So we have the region of interest is now over Spain and Portugal. We are interested about 16th of August this year, and we are setting the time between 11 and 12. And now let's see how many products we will find. Okay, so were found 2 products that overlaps with our given region of interest. In this course, we are only interested in the netcdf file, so we can even more reduce our search so that we want to search only for the specific netcdf file. So we are leaving out all the CSV files that comes with the original product. So we are only interested in these netcdf files. So we can now specify the search even more, that we specify that we want only the requested file, and we got it now downloaded into our workspace. So now under products and FRP, we should have here the two data folders where we have the two products, and you can see that there is now only the file that we requested here, nothing else. So this is the way how you can then narrow down your search. And now we are actually doing exactly the same thing, but now for the near real-time AOD. So the procedure is exactly the same. The main difference is here now, of course, the collection ID and then the requested file. So now we don't have any FRP files here, but we have the near real-time AOD file, a netcdf file. And here we are actually doing everything now in exactly the same way as for FRP, but now for the AOD. And let's hope that we will get the products. Yes, okay. So 2 products found over the given region of interest, and it had downloaded the data, and now quickly just check that the data came in. Yes, we have here and we have the NRT AOD files as we requested. So this is basically this was basically the first notebook, and then I think we just then go directly to the second notebook, how we mainly visualize the data. So I would say that this is very quick now, and if you go back to the recording, so maybe you can then repeat this by yourself. And if you encounter some errors, for example, the licensing, so our contact information also is found from the slides and so on, so you can contact us if there is some issues now with the licensing and you get errors due to that. And again, when I'm opening here for the first time the second notebook, so it asks me which kernel, so now we already know, we know this thing, so it's Vekeolab, and we select that. So, and now the second part of this training is really visualizing the data. So again, we have here a lot of information about these specific products, which we have already discussed, and we also have some explanation about the case that we are studying here. So it's the mid-August and over Spain and Portugal. And what we go here is that we are downloading again the needed libraries that we need to run our functions. And here we have now also the loading, we are also loading the helper functions. So if you wonder what on the earth is this, so this is actually a collection of functions that maybe that Noemi and the team has developed to be a little bit to be able to a little bit more easily to read and visualize the data. So this has these functions are made for you to be able to more easily work with the data. But for this notebook, we also need to import these helper functions. So now this notebook knows when we call these functions from the helper functions file, so they know the code knows where to find those. And we are using, first we are visualizing the FRP data, and the data is in NetCDF, and we are using the Xarray to open the data. So we have the data now in the folder. So this is the data file name, the data folder name, and it is under the products. So products here, Sentinel-3 FRP data folder, and then we have the file name there. And we are using the Xarray now to open the data. And you will get the Xarray dataset here. You can here by clicking, you can see what kind of variables are inside the product, the NetCDF file. And what I maybe could point out here also is that here are the dimensions of the file. So the FRP data is given as 1D data. So it's basically points in a space. So this is not a gridded data. This is not a 2D data as the many other satellite observations are, but this is kind of one-dimensional data. So there is basically a point and latitude and longitude. So in order us to be able to plot this our data variable, so we need to read the latitude, longitude, and start and stop time. The start and stop time can be found under attributes and data variables, the latitude and longitude.
Anna-Maja, sorry for bothering. It's already 14, so just for you to know.
I try to do it this quickly. So there is all kinds of masking of the data. So what we need to also do in order to get the good quality data. So we are generating, for example, the masked array. We are throwing out some bad quality pixels, and then in this case, though we didn't have bad quality pixels, so the length of the after masking, the length of the observations is exactly the same as before the filtering. In this approach, we are now using we are gridding the FRP data. So we are gridding it. We are not plotting those as a point directly on the map, but we are gridding the data. And here we are really defining the grid. So we are getting the geographical bounds for the grid, and we are giving the grid cell size as decrease. And then we are also defining the maximum value for the FRP that will be shown on a map. And now you can see here on the notebook that apply function SLSTR FRP gridding. So this is now coming from the helper functions, so from here. So you are basically giving have a number of input parameters, and this function then will do the gridding for you. Yes. You will get 3 arrays shown here. So first are the actual FRP values, then the latitude and longitude grid. You will see here the -999, that means missing observations, not bad quality observations. So we are glad that not every cell has a number, because when we have a missing observation, we have no fire. So we don't want the whole world to be on fire. So that's why the -999 values are appearing there. We can also mask the -999 values away, and then we can proceed with the actual plotting. There is also this is really an extra statistics calculated from the data that will be appearing in our final plot. But the actual plotting is done then here, where you again call the visualize S3 FRP function. So that is visualizing the gridded FRP data, and what you would be getting is really the gridded map. So you can see very nicely where the fires were, very intense fires, a lot of fires that have values greater than 500 megawatts, and the statistics are shown here at the side of the plot. As we are quite short on time, so the approach for doing or plotting the AOD data is very similar. So we are reading the AOD data with X-ray. We get the arrays for the AOD, and the parameter that we are using in our analysis is the AOD 550 merged ocean and land. So this is the AOD that is retrieved both over ocean and land, so it extends over water and land surfaces, and we are using that latitude, longitude, start and stop time. And this merged ocean and land AOD also contains already some quality filtering, so we can use this as it is. So we don't need to use any kind of additional filtering for this. And we can calculate again some statistics from the data. So this is now the corresponding data that we had the FRP. And then we could then run and visualize the Sentinel-3 AOD. So again, this function is coming from the helper functions, and let's hope that this is now working. Yes. And here we have the corresponding. So we had first the FRP plots, and now we have the AOD plots. And so basically, these are the two basic tools that you can use to visualize these two SLSTR data. And there is an additional also way to plot these two data is next to each other. So you can see where the fire source areas, and then you can actually see how far the smoke plume is transported from these fires and how much aerosols there really is, that the values of the AOD are exceeding even 1. So this was like really speeding up with the demonstration, and I think this was the full now demonstration. And is it time for a Q&A now?
Thank you so much, Anna-Maja, for your demonstration, and thank you everybody for following and listening. We know that there are a lot of things, but these trainings are on purpose, so you can come up later and rewatch this, and so you will be able to as Anna-Maja mentioned before, to stop and try things out. Of course, there are a few questions, so please feel free to keep on asking on the chat or on the questions and answer. We can already go through some of them. And I would like to, first of all, let you know, answering some of the more logistical questions, and then we go for a bit more scientific ones. This recording will be available for you on the classroom page. Noemi has shared the link on the chat. Please let us know if you have any trouble, but it's really easy. You can just go to classroom.eumetsat.int. You will be able to find in the short courses, in the cross-thematic webinars, you will be finding this specific course. It's open to the public, so you can access it at any time, even if you want at the end, like next year, you're also going to be able to find it. So for anything that is regarding the access to these resources, you will have it, and do not worry about that. You will have the presentation as well available for you with the right links, and you also will have the link to the GitLab where Anumaya has showed you. So these Jupyter notebooks are available for you. Everything that we show in trainings are usually available for you. So these type of trainings are scheduled on purpose for open groups, so you will be able to find all the resources as you wish. If you have any technical question that maybe while you're working with your data or you cannot figure out the licensing, or any technical question you might possibly have, remember you can email ops@eumetsat.int. This email will be directed then to the right people. So even if you have questions that are related to the actual interpretation of the data, that is something that can be answered from EUMETSAT, of course. You're free to also email ops@eumetsat.int. Maybe Noemi, you can type this. Thank you so much. If you could just ops@eumetsat.int, so everybody will be able to just email this, and the questions will be directed either to us or to data engineers, or it depends, of course, on new type of questions. But any question you have, ops@eumetsat is the place. If you have questions about training courses, please do email training@eumetsat.int. Also, this will be directed. If you have questions about our trainings, will be directed to us. So do not worry if you have any question. Feel free to email either ops or a training. So it depends on the type of question that you have. Okay, so there are a few questions that I would like to touch. One of these one is from Andrea. He's the person that has asked a question. Is LEADER technology going to be implemented for wildfire monitoring in the Copernicus program? I don't know, Numaya, if you do have an answer for this.
Nope, I think I don't have answer. So,
Okay.
what I could say is that Copernicus is already supporting a lot of this wildfire monitoring. So it has the EFIS service and all the multiple satellites and the CAMS data, also the model data that can be used for wildfire monitoring.
Thank you so much, Anumaya. Yes, so we are also going to publish soon a new guide for you all. So you will also be able to find a lot of information, but this is still not available. This is a bit of a spoiler for everybody. But you will be having also this. If you want to expand this conversation, again, feel free to email ops@EUMETSAT. So the people in charge will be, if we have an answer, well, probably somebody within the whole EUMETSAT will have an answer to this, and you'll be directed to that person, if that's okay, Andrea. Then we have a question from Sergio. Could be Sergio or could be Sergio, depending if you are, where is this coming from, but maybe there is another pronunciation I'm missing. Are there any products of polarimeters of aerosol identification used or intended to detect biomass burning, smoke from fires, or from other sources like dust? Anumaya, can you answer this question?
Yeah, I'm not sure really like what type of instrument is this of question, but what I can generally say is that there are multiple type of instruments that are used for monitoring all kinds of aerosols. Optical imaging, this kind of that we just demonstrated. Then there is also active remote sensing with lidars and so on, polarization measurements and all this kind of different kind of combinations, a little bit depending on what type of information you would want to have, and on what type of aerosols also.
Thank you, Anumaya. Sergio, I saw that you said Spain, so it's Sergio is the right pronunciation, I hope. So if you feel like you want to, you haven't want to clarify your question, or is this Anumaya's answer clarifying or satisfying enough? Just let us know in the chat. We'll monitor. Okay, so there are a few more questions. So how can we know the interest file name? I think I don't know if I know what you're meaning with the file name. I think you were meaning the collection ID. So the collection ID, as I showed it to you, you can either see it on the actual data store. But there is also some important guides. If you go to the detailed guide of EUMETSAT, and you go through, for example, the data tailor table that is within the list of useful information, and in the detailed guide, you will be able to find the names. But you know what? We can put a nice link for you to check out on the page, on the classroom page. So I'm writing this down for us to do, and we will add you a link where you will be able to see to this table that is really good. So you get to see all the different products that are available. You can filter the products, and you can see the ID. So you can either do it as we did before with the presentation when I was showing you the GUI of data store, or you can do that through that. So we will add you a link in the resources page. Okay, I think I have more questions. Give me one moment. Mohamed was asking how to contact you if you receive any errors. This is again ops@eumetsat.int. So if you have any question, you can always email, and then depending on your question, will be directed either to us or to somebody else. Okay, so let me see if I see in order the questions. And if you feel like I'm missing your question, feel free to let me know. So you just let me know if I'm missing something. Okay, so I think are the high AOD values above Spain the result of the moving fire plume? Georgios is asking.
Very short answer, yes.
Yeah.
You're very correct, yeah.
Yeah, very
So
correct.
the plume is moving, so it's emitted and then it can move actually very long distances. So even here in the north in Finland, we can sometimes observe the fire plumes coming from the Canadian fires.
That's super interesting. Okay, thank you, Georgios. If you feel like you want to ask more questions, feel free. And we still have 15 minutes. Okay, you're asking for certificate of attendance. So short courses usually do not have the certificate of attendance. So we don't really send the certificate of attendance for short courses. If you really need it because you need to prove something to your employer or something like that, please also email training@EUMETSAT. So we can try to understand if we can do that. Usually short courses like this one, because it's just 1.5 hours of your time, and don't usually have the certificate. But if you really, really need it and you cannot deal without it, please email training@EUMETSAT. Thank you. Okay, so we have another one. Why is aerosol optical depth measured only in VIS and not in IR?
This is this is not, I would say that this is not entirely accurate what I said, that it is only measured at visible wavelengths. So the use of the visible wavelengths is based on that the aerosols scatter and absorb light, and they affect the radiation at that wavelength. So the satellite is only able to observe aerosols at those wavelengths that the aerosols kind of interact. So if you use different wavelengths, so you don't see any aerosol signal there. So that's why the visible wavelengths are always used or most often used for aerosol remote sensing. But there is one specific case, which is the mineral dust, so dust coming from deserts. And for that, you can use also the infrared observations. But it requires that. Why dust? Because dust is also affecting the thermal signal that the satellites can measure. Other types of satellites do not affect the thermal signal. So that is why for all kinds of aerosols, we are using the visible wavelengths because they are sensitive to all types of aerosols. But then for the thermal infrared, we can use specific type of dust.
Thank you so much, Anumaya. Okay, we have a few more questions. I'm going through them because we have only 13 minutes, so let's see if we can go through them all. So the first thing, Bubakar, I hope I pronounce your name correctly, is asking for the link of the layer names metadata of this NetCDF. And no, would you mind maybe sending him the IDs for the two, or her or them? Sorry, I assumed. Maybe you can send the ID, the collection, the collection ID and the product ID.
Yes, absolutely.
Thank you so much. Now we have another question. Can you please share some basic mechanisms or algorithm used to calculate Sentinel FRP?
Yeah, so actually the calculation is FRP is something that is done at the, so there is a specific algorithm that is not publicly available, so that is operated by EUMETSAT. It is a result of multi-year, like let's say, development, and typically these kind of algorithms are not like publicly available. So what you can use is actually the end product, so the FRP itself. So the FRP is, for example, compared to AOD, is a little bit more simpler parameter to get from satellite observations, but still like calculating it with your properly with your own laptop, for example, it's maybe a bit complicated. So you need to do a lot of the level 1 data, so the radiation data from satellites is really heavy first of all, and then the calculation is not like very simple. So if you want to use the FRP, so please check the EUMETSAT FRP that is provided near real time. So as you could see in my notebooks, we already have observations from today available in the data store.
Thank you so much, Anumaya. Okay, more questions. Is it possible to retrieve the wildfire directions from FRP and AOD parameters? Wildfire direction.
Yeah, so basically the atmospheric emission, so the smoke plume is going where the wind blows. So it is when it's emitted, so then it's up there in the atmosphere, and it will follow the winds where the winds are like going at each atmospheric layers. There is a certain additional parameters available for the fire analysis, which are the if I now remember correctly, the fire perimeter or this kind of things that really are used to monitor the fire direction, so the where the fire is progressing. So such parameters are available from satellites, but they were not covered in this course. So I would say that like only the FRP and AOD are not enough for you to really to define where the fire is progressing, if that is meant by the direction. So to which direction the fire is spreading. So that is, I think the FRP are not maybe enough.
Thank you so much, Anumaya. So again on FRPs, are MTG FRP and MSG FRP products also as easily accessible like Sentinel-3 SL SDR products?
Yeah, I think, well, depends on what you are used to. So the MTG FRP products also fall into the land LSA SAF products. So they are also available with the SAF their distribution channels. and so on. So, but basically, it is, I think, fairly easy to use the both data. Yeah.
Okay, thank you so much. So there is other two questions that I would like to go through, and then I would like to show you the classroom so you all know where to find this recording. So are there any other data sets? Okay. Are there any other data sets that can be used with AOD to distinguish fire plume from dust and/or other particles?
Yes. So from dust, so there are some. So to distinguish whether the AOD is due to dust or due to fires, so first I would go and look at the FRP observation. So if there are fires nearby, and you can kind of see that the AOD is kind of having a plume that ends up with the fire region, so then it is most probably fire. Also, if you would look at the AOD together with, for example, carbon monoxide observations from satellites, and if you would see that the AOD is spreading the same direction as the carbon monoxide, for example, so then you would be also quite sure that that is really from the fires. So that can be used. So let's say other atmospheric emission products that are produced only by fires, but not, for example, by dust emissions. So analyzing multiple variables together can be used to really to define the origin of the aerosols.
Thank you so much, Anumaya. Have other questions. Thank you, Anumaya, so much for this. You were okay. What is the purpose of having different channels for FRP divided into SWIR and MUIR? I don't know if I say it correctly. Do you spell it, or we say it's MUIR and SWIR?
Yeah, I think it's mid-infrared. Yeah.
Okay, good.
Yeah.
Also, thermal IR2, IR2, which is more sensitive.
So I'm also must say here that I'm an atmospheric scientist. So this kind of FRP observations, like they are always like supporting my analysis, but they really fall outside of my really expertise. But what I have understood and what I know is that these different channels are sensitive to different types of fires, and these mid infrared channels are very good for especially for vegetation fires, so those that are originating when the wood is burning or some like vegetation is burning somehow, so the mid-infrared is most sensitive for that kind of observations. And then if you are interested in some other type of, let's say, more like these industrial emissions that are not really fire, so then you might use another type of FRP.
Thank you so much, Anumaya. I think I will go through this one more, and then we'll have to go through, yeah, through the classroom just to show you. Are there any validation studies or documentation available for these products? In my personal experience, many fire products are overestimating at many regions. I would suggest to have some collaborative research for the validation of these products. Thank you, Mohamed, for that. But do we know if there is any?
Yeah. Yeah, I think the validation is like it's a very basic when you operate this kind of and you operationally produce this kind of products from satellites. So that is very basic exercise that you always carry on all the time. So there are definitely validation ongoing all the time, and based on the validation studies, so then they are able to also upgrade the algorithm, correct some apparent errors if there are some, and so on. So the validation is very, very important part of the whole satellite business when you are developing this kind of data products. So definitely there are existing already, I think, articles already, and also EUMETSAT should have also their own validation studies available. I think they are linked through the data catalog under the resources or something, if I remember now correctly. But definitely, so this is thank you for bringing up this point. So this is very important because if these satellite products are not systematically and constantly validated, so they are basically maybe of no use because nobody knows how good they are. So you really need to monitor the goodness of the product all the time.
Thank you so much, Anumaya. And thank you, everybody, for sharing links, sharing your opinion, and also sharing what you know. It's really helpful, and these trainings are on purpose for that. I will now share just the page so I know, so I can be sleeping good tonight, that you know where to find this recording, okay? So I'm sure that you'll find it. But also, please be patient with us. We will be sharing it as soon as possible between today and tomorrow. So you'll probably find all the resources by tomorrow. Okay, so let me share 1 second once more. Okay, this is the classroom page. This is where you'll find all the courses, okay? For all the different information that you want, guides, it's the user portal, but for actual courses and all the resources of the courses, it's here. So you will find this course under classroom.eumetsat.int, really easy. Then we're going to more. We are going to courses and workshops, cross-thematic webinars. We click, and then it's right here, short course 51, Visualizing Fires in Spain through Sentinel-3 data. Okay, it's right here. It is not under atmospheric composition, it is under cross-thematic webinars. This is a short course, so it sticks within this category, okay? So here you will find everything, all the things that we've talked about, and you will find here within the recording and resources, you will find this recording. Okay, so everybody, thank you so much for joining. Thank you so much, Anumaya and Noemi, for your work. And I'm really glad to see many of you joining today. If you have any request, anything that you think, oh, we really would like to learn as a community, we'd like to learn about this, and that, we really do value your opinions. So please let us know. If you have any feedback, feel free to let us know. Also, really, really important, everybody, before you all leave, there is a survey for this training. Please do answer the survey. It's also that in class, on the classroom page under surveys. So please do let us know what if you have anything that you would like to know. Thank you, and thank you, Ruta, for the link. And we are going to let you go for the moment. Thank you so much. Don't hesitate to reach out if you need anything. And I wish you a great rest of the day. Thank you, everyone.
Thank you.
Thank you so much, everyone.
Thank you.